This video is about multiplying and dividing rational numbers, specifically talking about decimals. So because we are looking at doing it from a 7th grade perspective in talking about rationals, we've got to go back and review a little bit about what happened in 5th grade and a little bit in 6th grade if they carried it over into that point in time. So let's talk about some multiplying facts first off. First fact, it doesn't matter which number goes where because of the commutative property of multiplication. We know that it doesn't matter if you're doing 2 times 3 or 3 times 2. Both of the answers when you're multiplying are going to work out to be 6. So it doesn't really matter which number goes where. So what number would you put on top or which number you put on the bottom? It just doesn't really matter. The second fact about multiplying with decimals is that we do not line up the decimals when we multiply because there's no borrowing or carrying going on. So we're not doing all this stuff. So we don't really care about lining them up. So our steps for multiplying are pretty straightforward. We're just going to follow our regular multiplication rules, just like we normally would when we go to multiply a 2-digit number by a single-digit or 3-digit number and so on. We would just go ahead and multiply, follow our rules, multiply the ones, multiply the tens, and so on. Second step, we would count the place values used after the decimal for both numbers that were multiplied. So let's practice doing that. Here I have 3 and 2/10, so it's 1 place after the decimal. Here I have 4 and 857 thousandths, which is 3 places after the decimal. The 6 has nothing past the decimal, so that's 0. And here we have 72 and 65 hundredths, which is 2 places past the decimal. So what we want to do is if we were multiplying two numbers, such as 3 and 2/10 and 72 and 65 hundredths, we don't line up the decimals, but we would probably take the number with the least number of digits on the bottom, go ahead and multiply, follow those multiplication rules, and then when we're finished, whatever number we would come up with, we would move that decimal because it would start at the end. Because this has 1, 2, 3 places, we would move that decimal 1, 2, 3 places, and that's where it would hold in the number. Okay, and this is all again like from 5th grade. So the last thing, like I said, start from the back of the solution like it's an integer and count the place values that was determined in number 2 and place your decimal there. So if we had multiplied those two numbers, like I just mentioned, and we came up with a number like 45,631, and we needed to move it 3 places, we would start at the end, go 1, 2, 3, place a decimal right there, and that's where the decimal would go. So pretty much straightforward, again, from 5th grade. So let's take a look at this. We have 6 times 3 and 5/10. Now, what tends to happen with students is that they'll start just putting numbers down and then starting to multiply. But remember what I said a moment ago, it doesn't matter which number goes first. So if you put the number with the least digits on the bottom, you will do less work. So I have 6 times 5, which is 30, 6 times 3, which is 18, and 3 more, which gives me 21. So I have 210 if this decimal was not here. But because this decimal has 1 place here, no places here, I need to move my decimal from the back of the number as an integer, 1 place, place it there. So my answer to this problem is 21. We're going to take a look at one more number, a little bit more complicated, a little more decimals all over the place. So here I'm going to have 1 and 345 thousandths, and I'm going to multiply it times 2 and 6/10. So once again, I'll do some multiplying here. Carry the 2, and that's going to give us 8,070. And then remember, when we start in that 10 spot or that second spot, we don't start here. We always start in the second spot. So go ahead and do this right all the way through. That'll be 9, that's 6, and this is 2. And then remember to keep your numbers lined up. Probably the biggest mistake I see is students don't line up their numbers correctly. And when they don't, they're not able to get the right answer when they add. So then we have this, and then we come back here and we look at the problem again. We have 1, 2, 3, 4 total place values past the decimal. So we'd start at the back of the number and we would move 4. 1, 2, 3, 4. We would place the decimal here. So our answer will become 3 and 497 thousandths. We don't need that 0. There are lots of zeros after a number. We just don't show them all. So that's multiplying. So let's review the rules for from fifth grade for dividing. Now, the trick about dividing is that we have to use long division. So the first number is what is being divided, and the second number is what you're dividing by. So when we have something like this, 20 divided by 4, what we would be doing is we would take that first number, which would go inside, and the divisor would go outside because I want 4 groups. I want 4 groups out of the 20. How many would I have in each group? And we know that 4 goes in 20 5 times because 20 divided by 4 is 5. So we can see where our placement is. That's probably the biggest mistake I see is students putting numbers in the wrong place when they are doing division of decimals. Second thing is, do not switch the numbers around because the commutative property does not apply. And what I mean by that is this, is that if I had 10 divided by 2 or 2 divided by 10, these would give me 2 different numbers altogether. So we can't move the numbers around and come up with the same answer. It doesn't work for division. It's kind of interesting to note that for addition and multiplication, operations that make things go up or get larger, you can use the commutative property there. But in properties, we're using operations where things are decreasing, like division or subtraction. You can't use the commutative property. You can't have things move around. So let's review the rules from 5th grade and talk about our steps for dividing. So our first step is set up your division problem accurately, which we just talked about a second ago. We're going to make sure that your divisor is a whole number. So this is kind of a tricky idea. So you might have to move the decimal to accomplish this. So in other words, we're going to take this 2, and what we want to do is we're basically multiplying it times 10. And when we multiply it times 10, it becomes a whole number, right? Because of that one decimal place here. So really, we're trying to change it and multiply it times 10. Now this is important because if we're going to multiply the divisor times 10, we're going to have to do some other things. So if we move the decimal in step 2, then you have to move the decimal for the number you're dividing for the same amount of place values. And then we'll talk about floating here in a second. So what you're going to do is this, let me look here. Let's say we have this 2/10 that we're just talking about right now. Now, if I didn't change it, if I just moved the decimal and called it 20, let's say, which of these is equal to? Is 2/10 equal to 20/10 or 20/100? Hopefully you all recognize that these are the same values, right? And you can see that when a 0 is added in the numerator, a 0 has to be added in the denominator. So in order to keep that fraction equivalent, in order to keep that decimal to be the same decimal, we have to move not only the divisor, but we have to move the number that we're dividing. So we need to move it in both cases and then float it up. And I'll show you what I mean by that when we do a problem. But I wanted you to see why we do that. So, and the last thing is just follow your division rules. So that should be pretty straightforward. So let's take a look at a problem. Here I have 6 and 85/100 divided by 5/10. So I'm going to, my long division sign, what I'm dividing, and my divisor, what I'm dividing by, is going to go out. So I need to turn this 5/10 into a whole number. So what I'm going to do is move that decimal one place. So now instead of 5/10, I'm actually going to be dividing by 5. If I moved it one place on the divisor, I have to move it one place in here as well. So I'm going to move it and then I'm going to float it straight up. So that's where that decimal goes. 5 will go into 6 one time. Now we're just following our general division rules, right? Bring down the next number. 5 goes into 18 3 times, giving us 15. Subtracting that, bringing down the next number. And we're going to keep on going until it terminates. And then you'll see that this is on the other side of the decimal. So it'll go in 7 times. So our answer to this problem, 6 and 85/100 divided by 5/10, would equal 13 and 7/10. Okay, which makes sense. I'm cutting this in half. I'm trying to double it. So that kind of makes sense. I have one more problem here I want to show you about long division before we start talking about now where does 7th grade come in. So let's take a look at this. In this one here, I have 99 and 156 thousandths divided by 1 and 2/10. So what I'm going to do is I'm going to move this decimal over and make it a whole number. So now it's 12. If I move it once there, I have to move it once here as well. So I'm going to come back here and put my 12 into 99 8 times. gives me 96. Bring down that 1. That'll be 2 times, giving me 24. Difference of 7, bring down that 5. 12 times 6 is 72. And I'm going to bring down this 6 here. And then we got 3 here. Now we're at 0. So our answer to this problem here is 82 and 63/100ths. Okay, so now let's take a look at how does this affect us in 7th grade. So in 7th grade, we've got to start adding positives and negatives. So let's take a look at how let's review our positive rules and our negative rules for when we are multiplying and dividing. So when we're multiplying, let's review it. When values have the same sign. So what I'm talking about is if I'm multiplying two positive numbers or I'm multiplying two negative numbers, we should remember that our outcome when we have the same sign is always going to be positive. Because here this would be like a normal, right? And this is opposite of negative sets. So the opposite of negative sets are positive sets. So when we talk about groups of, we can see that it doesn't matter if I have two positives or two negatives, I'm going to end up with a positive solution. Now, what about when values have different signs? Well, right away, we know that the word different tells us that things will be different. These are either positive, negative, negative, and a positive. Both of these yield a negative solution because we're putting the opposite, we're multiplying an opposite. We're taking the opposite of a positive number or doing the opposite of negative sets. So we want to make sure that we have that minus sign. So again, these are rules that we've talked about before, and you can go back and look at our integer videos. Now, how does that apply now with dividing? Do we treat the signs the same or different when we talk about division? And we know that we treat them exactly the same. So whether we're doing different signs or we're doing the same sign, if it's different signs, it's still going to be negative. If they're the same signs, it's going to be positive. So what then becomes our steps for when we do decimals in the vein of 7th grade, when we're including positives and negatives? First thing you do is just determine the outcome of the signs. So look at the problem and see what's happening. If you see two positive numbers, you know your answer is positive. Two negative numbers, you know your answer is negative. If you have one of each, oops, I'm sorry, I just misspoke. If you have two positives or two negatives, they will both be positive. If you have one of each, it is going to be negative. So follow the rules for multiplying or dividing decimals depending on the operation after that. So let's review here. Here I have a negative divided by a positive. My outcome for this problem is going to be negative. Here I have a negative divided by a negative, negative times a negative. And if I was to multiply these two together, my outcome will be positive. So if I determine the outcome of my signs first, and then just go ahead and divide, or then go ahead and multiply. That's how we treat it in 7th grade. That's the one thing that changes it. So you really got to have that number sense down about how to multiply and how to divide decimals. Hopefully this video has helped you out.